Hey everybody, Happy New Year. I'm excited to demonstrate a brand new release of my Voss volume Voxelator for the new year. And I just wanted to show you how excellent it is. So here is the old 1.3 version that I released, 2010 at this point. Um, Takes a little bit of time. All right, well, after 56 seconds, we have our result. Now let's run the same thing with the new version. So before it took 56 seconds, let's see how long this one takes. Let's see. So 56 seconds. That's 7 seconds. Wow, it's much faster. But what kind of results did we get? Um, you switch windows here. We could see 56 seconds, 7 point. These are previous numbers. The numbers are pretty close. Why are they different? Well, I went and I double checked, so the new version produced the exact same output as the old version, but it turns out the old version I was using floats instead of doubles, so there's always a little bit of slight rounding error. So 4.67 versus 4.7, not 9.77 versus 9.76, and that's where the rounding error comes into play. So let's do another example here. So that was with a small probe of 1.5. Let's do it with a larger probe. So probe size of 9. All right, so we can see the old version took about 19.67 seconds. I'll log that down for later. Let's see how long the new version takes. Because this is using a probe of size 9, there's a lot of points to kind of be excluding each time. So the speed up isn't nearly as fast, but it's still pretty fast. So we went from 19 seconds down to 7 seconds. One other cool feature of the new one is, before we had to do all the conversion to XYZR files. I don't know, anybody that's used these programs kind of familiar with the PDB XYZR script. I've written one in Python, but now the C code is able to do that as well. So I can just give it the PDB file I directly downloaded from the internet. And in this case here, I'm going to, so I can be the exact same ones as before, I'm going to exclude ions, ligands, and water. Thinking to myself here, I should have an easier flag to flag that. But I should get the exact same result as before. So before it took 7.7 seconds. Let's see, 7.85. So let's take a look at our results here. So as you can see, the new, if you use an XYZR or a PDB, you get the exact same result, same number of atoms, but you can see it's PDB versus XYZR. Surface area, again, a little bit of rounding error in the old version, but the new version fixes that. So is the number slightly different than before? Yes, but they are the correct numbers versus ones that are kind of rounded. I guess I could create a version 1.31 with the fix, but I would think, given how much faster this is, I would definitely go with that. So let's try one more demo. And this time I'm going to try it on my favorite ribosome structure, and that is 1JJ2. All right, that took 25 seconds. I'll put that down in my text file here. All right, now let's try it with the new version. My last test, it took about 5.5 seconds here. So it shows a probe size of 3 and 401, 531. Yep. But again, I can do this with the PDB file. So 1JJ2.pdb, 3 exclude ions, excludes water. Works with 90,400 atoms. Man, I used to run these jobs overnight. So ridiculous. It does take a little bit longer with the, having to read all the atoms in, because the XYZR part was already kind of done for the other program, which, takes some time. And you can see here that the 1 million volume cubic angstroms, 521.283 versus 401. The surface area kind of dropped by half an angstrom square, but we're looking at 9,418 atoms each time. And it's just an incredibly faster program. I don't want to get into the deals, but basically I was able to kind of, instead of, calculating spheres all the time, I was able to just kind of give it a list of points to kind of erase. So this is a quick video, and I'm going to stop for now, but I do have another exciting announcement related to Voss Volume Voxelator that involves Docker Podman containers, and I will do a separate video for that. So thanks.